Hi everyone, this is our lecture video on section 6.1, the composition of functions. So what exactly is a composition of functions? So the composition of functions is a function operation denoted by an open circle Pardon me a moment, everyone. I'm having a hard time using my stylus here. There we go. The composition of functions is an operation usually denoted by an open circle. Let f and g be two functions. The composite function FOG, this is read as f composed with g, is defined as follows. F composed with g of x equals f evaluated at g of x. The domain of f composed g is the set of all numbers x that are in the domain of g, for which g of x is in the domain of f. And I have drawn a diagram example here of what a function composition looks like. So function compositions are basically just taking a function, you plug in an input into a function, and then you take that function and you plug it into another function. In determining the domain of a composition of functions, you need to exclude any values of x that are not in the domain of the innermost function. So in this here, f evaluated at g of x, the innermost function is that g of x. So any x not in the domain of the innermost function have to be excluded, and you also need to exclude the values of x for which g of x is not in the domain of f. So we're taking functions, plugging in an input, taking that and plugging it into another function. So we've got two examples here. And I'm going to do one of these examples. The other example I will do in class. For the given functions, we need to find the following compositions. Let's start with part A. F composed with g of 4. Okay. The two functions f and g are listed. F composed with g of 4. This equals f evaluated at g of 4. Look at that function g. That function g is 3x squared plus 1. Wherever I see an x in that function, I need to plug in 4. So this is f evaluated at 3 times 4 squared plus 1. 4 squared is 16. 16 times 3 is 48. 48 plus 1 is 9. 49. So I now have to look at f evaluated at 49. This equals 2 times 49, which is 98. When you're looking at function compositions of a number, you have two options. You can either evaluate the innermost function first at the number, take that result, and then plug it into the function. Or you can find the general composition. So like for this one here, part A, I could have found f composed with g of x, simplified that result, and then plugged in 4 for x in my final result. To give you an idea as to what that looks like, this is f evaluated at g of x. So this is f evaluated at 3x squared plus 1. Look at the function f. Wherever I see an x, so let me circle it. That right there is the function f. Wherever I see an x, I need to plug in that entire thing, 3x squared plus 1. So this is 2 times 3x squared plus 1, which is the same thing as 6x squared plus 2. So if you wanted, you can plug in 4 into that very last simplification there, and you'll get the same result as we got in part A. This is 6 times 4 squared plus 2. 4 squared is 16. And 16 times 6 is 96. 96 plus 2 is 98. So same answer. It's up to you as to how you want to do this. Let's look at part B of this problem. G composed with f of 2. So this is G evaluated at f of 2. F of 2, this is 2 times 2, which is 4. So this is G evaluated at 4. G evaluated at 4 is going to simplify to 49. Part C, you have f composed with f. That looks really strange. You can, in fact, do a function evaluated at itself. This is f evaluated at f of 1. F of 1 is 2 times 1, which is 2. F of 2 is 2 times 2, which is 4. The very last one, I can fit this here. This is G composed with G of 0. This is, let me move this over here. This equals G evaluated at G of 0. G of 0 is going to simplify to 1. G of 1 is going to be 3 times 1, which is 3, plus 1, which is 4. In function composition, the order matters. This is not a commutative operation, okay? If you have this right here, let me scroll down. So that next problem, we'll do it tomorrow in class. So if you have f composed with g of x, this is not the same thing as g composed with f of x, okay? If this is brand new to you, you're going to want to write out this additional step here. You need to deal with this innermost evaluation first, and then you will deal with the evaluation of that outside function, whatever that function may be. For the given functions f and g, we need to find the following. So, these questions here that I listed, they are in your textbook. And we also need to state the domain of each composition. So you have these two functions, f of x and g of x. For part A, we need to find f composed with g of x. This equals f evaluated at g of x. What is g of x? G of x is that function 2 over x. So now what do we do? Let me circle f of x for a second. You see that right there? That's f of x. Now take a look at what we have here. That says f evaluated at 2 over x. What do we do? Wherever I see an x in the function f, I need to plug in 2 over x. So this equals 3 over 2 over x minus 1. I'm going to simplify this result further. Right now we have a complex fraction. The denominator of that complex fraction can be written as 2 minus x over x. So all I did there is I just subtracted those two fractions, right? Found a common denominator. Now here I have a number divided by a fraction. These kinds of ratios come up all the time in calculus, okay? You need to take the denominator of this gigantic fraction and multiply it, take the reciprocal of it and multiply by the top. So this simplifies to 3x over 2 minus x. Now what? It says we also need to state the domain. It didn't tell me to write this in interval notation. For this video, I'll just write it in set builder notation. So our domain is going to be all real numbers. Now, what are we not allowed to plug in? Okay. When you're looking at the domain of a composition, you need to look at the values of x that you obviously cannot have after the simplification is done. Take a look at this. I'm pointing at it with the red arrow. I can't plug in 2 into that function, right? That gives you 0 on the denominator. So for sure, x cannot be equal to 2. What else? You need to exclude the values of x in which g of x, or rather, I shouldn't say g of x, but rather the innermost function is undefined. Your innermost function in this problem is g of x. Look at that function g of x. I'm pointing at it with the red arrow. When is that undefined? That's undefined at 0. So x cannot be equal to 2, and it cannot be equal to 0. This is the domain of this function in set builder notation. This is what that answer looks like in interval notation. You can plug in any real number with the exceptions of 0 and 2. I'm going to do another one of these. Let me do part B, g composed with f of x. Part B, g composed with f of x. This equals g evaluated at f of x. So for that function g, wherever I see an x, I need to plug in the entire function of f of x. Just like that. What do we have here? We've got something divided by a fraction. What do? Take the reciprocal of the bottom, multiply it by the top. So this thing will simplify into 2x minus 2 over 3. All right, now what's the domain? Sorry about that, my keyboard's messing up here. So what's the domain of this guy? Your domain has to be all the values of x that won't satisfy the simplified composition. Let me circle this for a second. You can plug in any real number that you want into that final result. So that's not a problem. But look at f. F of x is this function, let me circle it on the top, 3 over x minus 1. I need to exclude the values of x in which 3 over x minus 1 is undefined. That happens when x equals 1. And that's going to wrap up this video. If you want this answer here in interval notation, it looks like this. Oh, oops, I forgot to end this video. Sorry about that. That ends this video, and I will see you when I see you.